Good day, everyone. Welcome to another robotics session. So this is to discuss a robotics workshop, reimagining the classroom using robotics. My name is Wayne Thompson, CEO of Untitled Electronics and STEM and robotics engineer. And today we will be talking about robotics. How can we use robotics in the classroom to make teaching and learning fun? Alright, so on screen, these are some of the robots that we normally use. So the first robot you'll see is a humanoid. We also use the VexIQ robot in our activities, and also another version, the aluminum version of the VexIQ robot. Robotics in the classroom. So what we'll be talking about is how can we use robotics in the classroom, and what are some of the benefits, and how engaging it can be, and some of the fun elements as well. So what we do here at Untitled Electronics is that we search for ways that we can incorporate new hands-on activities in the classroom. So on a day-to-day basis, we'll brainstorm with the different team members, and we'll perform activities, we will design activities, and we'll test them through. And these are some of the activities that we do using robotics in the classroom. So in the classroom, to investigate linear motion, we use robots to investigate linear motion. And in the STEM activity manual, you will see lots of those activities. We investigate nonlinear motion, speed, velocity, and acceleration. Also, we do log graph activities, investigate digital systems, and of course, using the Arduino platform, we use sensors to do data acquisition. So we show students that they can get information from electronic devices, and also we can use those electronic devices as well to make decisions. These electronic devices normally gives us a voltage value. Those voltage values are numbers. We can manipulate those numbers using mathematical formulas to give us different outcomes. So right away what we're doing is that we're linking classroom activities with real-world hands-on activities. What we want is for students to see that what they're learning in school is relevant and it can be applied. And so it is not just sitting down and studying, and the information that you're reading will never showcase itself, or you'll never apply it in the real world. We're showing them from day one that it is applicable, so that we can beef up enthusiasm amongst the students, and also so that we can allow the students also to have some sense of appreciation of studying. So we do data acquisition in chemistry, physics, and geography, linking formulas with real-world systems. And of course, a lot of the activities will allow us to do critical thinking, computation thinking, and of course, the Internet of Things. So a lot of the other sensors that we use, like the Wi-Fi sensors, Bluetooth sensors, the GSM module, is to also now incorporate different features in our robotics activities to kind of bring industry to the classroom, high technology to the classroom, where students, the light bulbs in the brain can go off, and thinking and discussions can pursue. That will make learning more meaningful and holistic. So in terms of mathematics, we can use mathematical formulas to control light. So that's a simple concept. So this is the Arduino platform. And of course, what we're looking at here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 LEDs. So some of the demonstrations that we'll do in the workshop is to show students that mathematical formulas can be used to control real-world devices. Alright, so we can allow, for example, if the area of a circle is above, say, 10 meters squared, we can allow 2 lights to be on, or 3 lights to be on, or 4 lights to be on. If the area has different values, we can allow different sets of lights to be on. So after doing mathematical calculations and inputting data into a system, we can use that information to control real-world objects, and that is one of the rationales. So mathematics, controlling light, that's one of the demonstrations that we will do in the workshop. of course, you have formulas in math and also you have formulas in physics. So the same principle apply. So for example, say for instance, we are calculating something like heat energy. We can say if the heat is between 10 degrees Celsius and 20 degrees Celsius, we may want the LEDs on pins 4 and 5 to be on. Or if the heat energy is less than, say, 2000 degrees, we may want LEDs on pins 10 and 11 to be on. Alright, so that's the concept. So basically, again, we are going to be using formulas to be controlling, alright, real world objects. So that's another thing. For biology, so how can we kind of incorporate biology? So what we will do basically is in the IDE, in the Arduino IDE, of course IDE stands for Integrated Development Environment. So in the Arduino IDE, what we do is to have some questions being asked as comment lines. And then now what we do now is when the student actually put in the right answer, then now we will trigger some effects in real life. So this is showing that strings or words that is written in a software can control real world objects as well and devices. So this can be used as a game. And we can think of different ways as educators to use this in the classroom. And of course, I'll be showing many examples of this in the workshop. For the arts, we can also, key terms can be programmed, and these key terms can be used to control any device. So that's what we use for the art. So we talked about what we did in biology. So the same thing could be for literature, the same thing we could do in history, the same thing we could do in social studies, or the same thing we could do in computer science, the same thing we could do in any of the different subject areas. So what we're doing here is us using computer science and hardware programming and the device, which is an Arduino, or some persons may use, we may graduate to a Raspberry Pi. We're using it, alright, to link what students are doing in school with real world applications. So we're kind of making links. And where links, for examples, are not readily seen, we can show that, information in the arts can be used to control devices in the real world. It's just a matter of what we want our devices to do. Alright, so some effects. So formulas control robots. Alright, so these are two robots designed by the KRW Electronics team. So we put together a robot. So we get different accessories. We research the different claw control mechanisms. And of course we use a PS2 controller for remote control. And of course the PS2 controller would send out a radio signal. And of course the radio signal, you'd have a transmitter and receiver. Alright, so that's some of the technology that we use. So one example of using robotics in the teaching and learning experience is to do an activity like this. So in many syllabi in the Caribbean and around the world, students normally investigate motion. Motion can be linear and motion can be nonlinear. So to investigate nonlinear motion using robotics and mathematics, of course the robot would be the tool. So we'll download an algorithm into the robot, and the algorithm would allow the motors to spin at varying speeds. And of course by spinning at varying speeds, it means that the robot would be basically accelerating. So the motion will be one where it is not constant velocity but rather varying velocity. So in this activity or experiment, we of course will use a desktop computer or a laptop. We use a Robot C software, or we use the Arduino software code. So any other robotics platform can be used as long as you have an algorithm inside to vary the velocity, because we're talking about nonlinear motion. So when you plot nonlinear motion on a graph, it's not a straight line, it's actually a curve. So in this example, the VexIQ robot is used, but of course also we can use the Arduino robot. The good thing is that in our software package, we have all the base codes. So in our software package, we have all the base codes that you can use. We have codes that will allow the students to accelerate the robots. And of course, those codes will allow the robot to be accelerated at different rates. We have codes to allow the robot to move at constant speeds. And of course, the students can allow the robot to move at different values of constant speed if they want. And of course, we have codes to allow the robot to move forward and backward to demonstrate the difference between distance and displacement, and lots more. So there are lots of motion scenarios that were programmed, and these codes will now be available. All right, so these codes will now be available for, of course, a low price of $10.99, so that's $10 US 99, or of course 1,000 plus Jamaican dollars. So in terms of the 1,000 set of codes, so that you will get for like $70, 70 US dollars for the full block of 1,000 codes. And of course, that is how the package is delivered. So in the experiment, of course, we're going to be investigating motion. So the good thing here is that there's lots of activities, very activity based. So you have rulers, we'll use a stopwatch, we'll use a laptop, and of course we use a robot. We specify VexIQ robot here, but it doesn't have to be a VexIQ robot. So whatever robotics platform, you will allow the robot to move forward with one wheel rotation. Alright, of course, then after one wheel rotation, you may want it to move forward another wheel rotation, but at a different speed. So what we're going to do is the input. What you will do here is the input. So what you do here is the input the algorithm into the robot. When the algorithm is in the robot now, the robot will be moving, and of course the student will record the distance at specific time intervals. Alright, so at different time intervals, you'll record the distance. Of course, you'll tabulate those results. So you'll have a column with distance values, and you'll have a column with time values. So when you record the distance and time values now, you'll then be able to plot a graph. What the graph will show you, how the distance is changing with time. Once you have a graph of distance with time, there are many types of information. Lots of information you can get from such a graph. By analyzing the graph, we can come up with the equation for the motion. For analyzing the graph, we can come up with the total distance traveled. From analyzing the graph, we can tell the distance covered at specific time intervals. In analyzing the graph, we can get things like the velocity from the graph by finding the gradient, or also we can find acceleration. So these are the different things that we can obtain from a graph. So from the activity where students are using hands-on, then they go right back into analyzing graphs in mathematics. So these are some of the measuring activities during the session. So of course we used an Arduino based robot, and of course there was an algorithm in the robot that allowed the robot to accelerate. And all of these activities can also be found in the KW Electronics STEM Robotics STEM Activity Manual. Alright, so these are more examples from the workshop, alright, where the participants analyze the motion and derive equations in the motion. This is a copy of one version of the book. We're looking to, of course, redesign the book, but this is the activity book that you can find with all of those types of activities that allow students to investigate different concepts in their physics syllabus or their general science syllabus or their mathematics syllabus. This is an example of an algorithm, and what this is saying is that for every 0.5 rotations forward, the speed is changing. So at 5% motor power, then at 10% motor power, then at 15% motor power, then at 20% motor power, 25% motor power, 30% motor power, 35% motor power, and that went all the way up to 85%. That information will be downloaded, and of So this, as was said, is a sample calculation, and of course this sample calculation is also in the STEM activity manual. So when you are doing it, you will have an example to follow. So combinational logics and robotics, we also show students that the zeros and ones that they're learning when they learn the AND gate or the OR gate or the NOR gate or the NOT gate or the NAND gate or any of the other gates, the zeros and ones, we can use it skillfully to control real-world objects. Also, we can use combinational logic to control real-world objects. So the aim of this exercise is to show students or the participants that the ones and zeros used in logic gates can be used to control real systems. And of course, class activities on logic gates can be explored in a hands-on manner, and laboratory activities can now be done in this area. Alright, so of course, a lot of times in the Caribbean and in Jamaica, we don't do a lot of hands-on activities where it comes to logic gate, when it comes to logic gates, or we don't do a lot of demonstrations, or we don't design a lot of real-world systems in order to show the students what's really happening, and so that they can have an appreciation. So I believe that there was the ancient times when there was a lot of talking and lectures and stuff like that, ushering now into the information age and the technology age. We believe that technology should not only be a part of the teaching and learning, but skillfully technology should be used to promote hands-on activities so that students can appreciate more what they are learning. So this was one example of a system that we use. So this is a combinational logic circuit, a combinational logic system. And of course, this system could be used to control any device or any other device that we would want to device, whether in industry, whether in biology, whatever the application, we could use a combinational logic sequence to control it if we desire certain types of outputs. So quorum sensing is the regulation of gene expression in response to fluctuation in cell population density. So this is a biological example. Quorum sensing allows bacteria population to communicate and coordinate group behavior, and commonly is used by pathogens, disease-causing organisms. So this combinational logic circuit, the rationale, what we'll want to do in this activity, the output of the combinational logic circuit is used to control a robot. Or we could use the output of the combinational logic system to control an LED, or it could control a light bulb, it could control a power switch, whatever we wanted to control. Alright, and of course, in the combinational logic, we can identify the type of gates. There are two AND gates, a NOT gate, and of course an OR gate. Activity 1, the participants will copy and complete the truth table. Alright, and of course that is by looking at the combinational logic circuit. And activity 2, state the input condition that will activate the robot and the LED at different points in time. Alright, so this is the truth table that the participants will fill out. And of course this will be coded into the Arduino, and so when the persons put in zeros and ones, they can see what will happen on the output. When they put in 1 0, they can see what will happen. 0 0, they will see what will happen. So based on these inputs, you will have a table of values. But in our system now, and in our STEM laboratory, putting this into the Arduino board now, into the Arduino IDE now, downloading the code on the board now, you will see that when you put in 0 0, something will or may or may not happen. You can now see how the inputs will control the outputs in real life. Alright, so you can appreciate what's happening here. So that's the string of activities that the participants did. So that's the string of activities. So the rationale of the entire series, the rationale of the STEM activity manual. The STEM activity manual was shown above. All right, so let's just go back to it so that persons can, you know, have an idea of what the manual looks like. It's a workbook, so students will write in the book. You'll perform your calculations, etc. So it's a workbook. You know, you put your name, the school's name, your email address. It's a workbook. You perform your calculations there. You write the tables there. Of course, you can plot the graphs and insert the graph there. In other versions, we're thinking of inserting graph papers inside the book as well at the back. So everything is just a one-stop shop. Everything is already there. So that's the idea. So the concept behind the book is to really allow students to have a hands-on approach to learning. All right, and of course, we'll be coming out with new activities. So stay tuned to the channel. We'll be coming out with new activities, and these new activities will be, of course, be compiled so that students and teachers and, of course, enthusiasts alike can engage in a new and more fun type of learning. I will borrow the word edutainment that I read from an article. So that's just merging entertainment and education, constricting the two and bringing it together. And of course, these are some highlights of some of our productions in STEM and robotics workshop. So the participants really appreciated what was happening. They really appreciated how we were using robotics. They really appreciated how academic it was as well. So after the data collection process and the interacting with the robot and the measuring instruments and the stopwatch and all of that stuff now came the plotting up the graph, came back the academics, came the finding the equation for the curve, of course extrapolation and interpolation, all of those terms and mathematical concepts came out of the entire process. So it is very academic as well. So these are some of the highlights from our sample workshops. So thank you for staying this long in a video like this. This is Wayne Thompson from KW Electronics, just going over some of the things that you may encounter in one of our workshops. And of course, we want you to also get a copy of the book, get a copy of the book, get a copy of the robot as well. So the thing is now this book works with a robot. All right. So basically it is general enough whereby you can type in whatever code necessary to allow your robot to move at a specific way. And of course, we use an Arduino based platform as well. So we have all of those codes to allow our robot to accelerate or move at constant speed or do other maneuvers. All right. So program it to do other maneuvers. And of course, we can calculate the average speed and all of that stuff. We can, calculate the displacement, measure the displacement to see if we're accurate. So we have all of those things considered in our STEM package. And the good thing about it is you can use any robot basically to participate in the activities. As long as you know that using your robotics platform, you may have to put in your own formulas. There are many different types of platforms there. So the book is very generic, whereby it can be used with different robotic platforms. So some of the platforms that we use at KW Electronics is that we'll use the VEX IQ, we use Arduino based robots. So we design Arduino based robots and use Arduino based robots. Found that Arduino based robots are very affordable and of course very extendable. So we can add devices as we go along, and we can add lots of devices. There are many hundreds of sensors that are compatible with the Arduino based platform. So that's one reason for using the Arduino based platform. So we are going to also be exploring underwater robotics with Sea Perch, the robotics kit, and of course what we do there is to show the applications. We want to bring out the applications, we want to bring out the physics, we want to bring out all of the different activities that's in the school curriculum, link it to the robotics practical platforms and have students engaging practically and in a hands-on way with the technology. So thank you. All right, so this is a copy of the STEM activity manual. Please grab a copy of the STEM activity manual. It's a workbook. All right, what we wanted to do, as I said, the emphasis is really on activity-based learning. So it's a workbook, whereby you will perform measurements and you record values in tables. There are lots of tables in the book, stuff like that. And of course, it's very, very quantitative. All right, you will do a lot of quantitative analysis. So, get a copy of the workbook and I will see you in another workshop. All right, so bye for now.